Greetings everyone. So in this video we are going to discuss about the carbonyl compounds. So first let's understand with the basic terminology carbonyl. What is a carbonyl compound? A carbonyl compound. So what basically a carbonyl compound is that carb indicates the alkyl group, and on the other hand side onyl, this part indicates that there is an oxygen attached to the alkyl group, and that bond which is present between the alkyl group and the oxygen is a double bond, because essentially the valency of oxygen is 2, so it needs 2 electrons to make itself stable, due to which it forms a double bond. So this group is known as a carbonyl group. This group is known as a carbonyl group. Now if you were to broadly classified, carbonyl groups are divided into two major types. Number one is the aldehyde group, and number two is the ketones. Aldehyde is having, if let's say if this is the carbon, oops, let me just draw a carbon. Let's say if there is a carbon, then if one of the carbon is attached to the alkyl group or aryl group R, and other carbon is attached to hydrogen, then it is known as aldehyde. And on the other hand side, a group which is having both of its chain attached as the alkyl or aryl groups, R over here, R over here, then it means that it is a ketone group. Now, if you just look into the structure of aldehyde and ketones, we now understand that they have a very general formula. General formula is like this. Um, General formula is like this: CnH2n plus 1 O, and over here it is also CnH2n plus 1. This is a very general formula, right? And now let's just move on to the structure. If we just look into the structure of both aldehyde and ketone, the very basic structure is like this, where carbon is having an sp2 hybridized orbital. Carbon is having sp2 hybridized orbital, and the oxygen is also having an sp2 hybridized orbital. Now, sp2 hybridized, there are three sp2 hybridized orbital of carbon, three sp2 hybridized orbital of oxygen. So let's just draw those structures. So let's say this is one sp2 hybridized orbital. I draw another sp2 hybridized orbital, and there is another sp2 hybridized orbital. Right? These are three sp2 hybridized orbital of carbon: sp3, sp2, sp2, sp2. Right? And alongside that, let me just bring it a bit here. Yes. So alongside that, I'm going to draw oxygen. I'm going to draw oxygen. Oxygen is also having sp2 hybridized orbital. Let me choose this color. This is one sp2 hybridized orbital. There is another sp2 hybridized orbital, and there is another sp2 hybridized orbital. These two sp2 hybridized orbital are having what we call as lone pairs. Lone pairs. And this sp2 hybridized orbital forms a sigma bond with the carbon. Now, this bond is a sigma bond, alongside which there is also formation of a pi bond. Let me draw the pi bond as well. This is the pz unhybridized orbital. This is the pz orbital. This is also pz orbital, and both of them, now there would be a sideways overlap which we call as the pi bond. The pi. So this is the structure. I'll write over here pi bond. Right? This is a sigma bond and there's a pi bond. And alongside that there is the carbon 2. Now carbon can be attached to any other, let's say if it is attaching to hydrogen, it can attach to hydrogen. It can attach to, let's say it can attach to any alkyl or aryl group. So it depends on what type of structure it is attaching to, on the basis of which the next bonds can be created. So um, let's assume that we are drawing the structure of formaldehyde. Formaldehyde basically it's having one carbon, formaldehyde. Let's say I draw the structure of formaldehyde. So if it is the case of formaldehyde, then I am going to draw a hydrogen here, a hydrogen here, s orbital of hydrogen, s orbital of hydrogen, and this will be a formaldehyde structure. The structure would be called as, the structure would be called as formaldehyde. Oops. And let me just drag it away so that it becomes easier. It's again the problem. I guess there's some problem with it. Anyways, let's continue with it. So this is a structure of formaldehyde. So what actually is there in formaldehyde? Both of the carbons are the both of the sides of the carbon are is having a hydrogen atom, which forms a formaldehyde structure. We were to classify its properties. Number one characteristic that we do consider is the state. Methanol and ethanol exist in gaseous state, while all of the other aldehydes and ketones exist in liquid state till carbon number 20. Above carbon number 20, they exist in waxy solids at room temperature. So this is the state. Odor, if we were to compare the odor of lower aldehydes and ketones, have a pungent smell, a very pungent and very very characteristic smell. But if you talk about higher aldehydes and ketones, they are having a pleasant smell. And if you were to compare the smell of aldehydes and ketones, then aldehydes have a characteristic aroma, while ketones have a flavoring aroma, which means they are also used as flavoring agents. So that's another important thing. Solubility, if you were to talk about its solubility, because of presence of carbonyl group, They have the capability to form dipole-dipole interactions, but they cannot form hydrogen bonding, due to which they are capable of dissolving in water and ethanol, but they are not as soluble as alcohol due to the lack of hydrogen bonding. And the solubility decreases with the increase in the number of carbon atoms in the alkyl chain. And solubility is like this: it is greatest in formaldehyde, and the then we have oops, it's formic acid actually. So it is greatest in formaldehyde, and then in aldehyde, and then in ketone. This is it. Melting point also follows the same trend. Melting and boiling point follows the same trend. It follows the same trend. What's this trend? Again, it is having the highest amount of intermolecular forces, due to which it is having the highest melting and boiling point. But again, if you were to look into the trend of melting point, boiling point with increasing number of carbon atoms, then it is proportional, directly proportional, because if we increase the number of carbon atoms, the melting boiling point increases. If we talk about reactivity, the carbonyl group, this is a carbonyl group, right? This is the carbonyl group, right? This carbonyl group is having a part is an electronegative oxygen, which makes it partially negative, because it draws the pi electrons towards itself, and that makes carbon electrophilic. And because carbon is electrophilic, that electrophilic carbon is attacked by a nucleophile. It is attacked by a nucleophile. And what type of nucleophile it can be attacked by? It can be attacked by a weak nucleophile or a strong nucleophile, depending on the type of catalyst we are using. If it is, let's say, acid catalyzed reaction, if the reaction is acid catalyzed, then in that type of reaction, what actually acid does is, acid basically releases its proton, which causes to acid releases its proton, due to which it causes to increase the electrophilic characteristics. Acid causes to increase the electrophilic characters of the carbon. It increases the positivity of carbon, because how does it increases? It basically attaches with the oxygen, due to which oxygen becomes less electronegative, due to which the carbon becomes more sorry, it attaches with it attaches with the oxygen, due to which it causes to increase the electropositivity of carbon, due to which it becomes more electrophilic, due to which a weak nucleophile can attack it. A weak nucleophile can attack it. Like likewise, we are having a base catalyzed reaction. So whenever we are going to do the reactions, we, of course, because of the presence of pi bond indicates that addition reaction will happen, and this addition reaction would be a nucleophile or electrophile. It would be a nucleophilic reaction, because attacking reagent would be nucleophile, and that nucleophilic addition reaction would be of two types, which is the acid catalyzed reaction and the base catalyzed reaction. So in a base catalyzed reaction, the nucleophilic characteristics are increased. Nucleophilic characters are increased. And how are these increased? These are in we are going to study in the general mechanism. Nucleophilic characteristics are increased, due to which it cannot allow a weak nucleophile to attack on the carbonyl compound. It necessarily requires a strong nucleophile to attack on the carbonyl compound. In this, we can also use a strong nucleophile, but in base catalysis, it is important that we only use strong nucleophile. We cannot use a weak nucleophile in a base catalyzed reaction. So this is an important thing. Now let's just understand few uh, methods for which we prepare it in laboratory as well as in industries. So a laboratory method of preparation of formaldehyde is pretty simple. We basically perform oxidation of methyl alcohol in the presence of platinum asbestos catalyst, or we can also use copper or silver catalyst at 300 centigrade, due to which we will get formaldehyde. Now what actually we do is, in laboratory we have this entire apparatus for the preparation of formaldehyde in the form of formalin. What formalin is? Formalin is a chemical which is composed. It's a solution basically, which is composed of 40% formaldehyde, 40% formaldehyde, 40% formaldehyde, 8% methyl alcohol, and 52% water. Now, this has a lot of biological applications. Instead, it is used for preserving biological specimens. It can be used as an antiseptic, as a disinfectant, as a fungicide. It can be used as a pesticide. So it has got a lot of um, applications. So that's pretty important industrially. So what we actually do is we basically connect the supply of air with we connect the supply of air with a beaker which is having the methyl alcohol, and that beaker is supplied with heat. That beaker is further connected to the platinized asbestos or silver or copper catalyst, and that is connected to the final beaker. So let's just understand the mechanism. What actually happens in this suction in this apparatus suction tube is we basically pull the air from the suction tube. We suck the air from the suction pump, due to which the air is derived in this. Air comes in this tube. Air comes in this tube. Air comes gradually. Oops. Air comes gradually in this tube and then goes into the methyl alcohol, a solution in water, due to which when methyl alcohol and air are heated at 300 centigrade, then it basically forms a formaldehyde, a mixture of formaldehyde, methyl alcohol, which is unreacted methyl alcohol, and water, which goes into this tube, which is a platinized asbestos, and that platinized asbestos, further heated up in the presence of catalyst, due to which a solution of formalin, methanol, and water, formaldehyde, methanol, and water. This is what we call as the method of laboratory preparation. But if we talk about industrial preparation, what we actually do is we pass the vapors of methyl alcohol with air um, at 500 centigrade, in the presence of catalyst iron oxide and molybdenum oxide, due to which we get formaldehyde. Second compound is acetaldehyde. Acetaldehyde is again is of a huge importance. If you were to understand acetaldehyde's preparation, what we actually do is we simply take ethyl alcohol and we perform oxidation of ethyl alcohol with the help of strong oxidizing agent sodium dichromate. When sodium dichromate is mixed with ethyl alcohol and pass through this apparatus, it is actually going to produce these things. It is going to produce number one, it is going to produce acetaldehyde, and there is unreacted ethyl alcohol, and there is water. So it is then passed through this apparatus, due to which due to which the water is taken out, and we what we actually get is by the way, this reaction is done in the presence of catalyst dilute sulfuric acid. So what we actually get is we get the water is taken out. We get water which is taken out from this container, from this suction tube, while acetaldehyde and ethyl alcohol is then passed through this container. And then one important thing about dilute sulfuric acid, which I just got it right now. Dilute sulfuric has got a really important role in this. What actually dilute sulfuric acid is doing over here? Dilute sulfuric acid prevents further oxidation further oxidation of ethyl alcohol. Oh, sorry, it's not ethyl alcohol. Acetaldehyde. Acetaldehyde. What actually it does is it prevents the acetaldehyde to be further oxidized into acetic acid, because we are still having the sodium dichromate inside it, due to which there are chances that it can further be oxidized into acetic acid, and thus form uh, you know thus form acetic acid. And in order to prevent that, what we actually do is we make it inert to oxidation, further oxidation, and then send it towards this container, due to which ethyl alcohol and water is separated out, and then a solution of ethyl alcohol and acetaldehyde is obtained. Now, in order to separate ethyl alcohol from acetaldehyde, we have a method uh, which is known as the formation of carbon disulfide. Carbon bisulfide. This is a carbon bisulfide test through which we can separate acetaldehyde and ethyl alcohol, or the alternative method is fractional distillation, through which we can obtain it. And there's another laboratory method. Basically, what we do is do a dry distillation of calcium formic acid salt and calcium acetic acid salt, due to which, when we are going to perform its dry distillation, heat them up, we will get um, acetaldehyde. Now there is another important thing which is about industrial preparation. Industrial preparation happens in such a manner that at industrial level, we actually take ethylene or ethene, and then we are going to pass ethene. Ethene is basically in the gaseous form, and that is passed with air in the presence of palladium chloride, copper chloride. Basically, palladium chloride is the catalyst. It is a catalyst, and copper chloride is the promoter. It is a promoter, and it is a catalyst. And what actually happens is there is formation of an acetaldehyde, or there is a formation of acetaldehyde. And another method for ketone. What actually happens is, when you're going to perform dry distillation of calcium acetate and calcium formate, then we are going to get acetaldehyde only. But when we are going to perform dry distillation of calcium acetate only, then it's going to produce acetone. So this is important thing. Now let's just move on to another important thing, which is about the reactions. Now there are three major reactions happening in carbonyl compounds. Number one is the nucleophilic addition reaction, which is further divided into base catalyzed and acid catalyzed reactions, and the other two types, which includes reduction and oxidation. So first, let's understand the base catalyzed nucleophilic acid addition reaction. So for the base catalyzed addition reaction, the general mechanism, the very basic and general mechanism is this. What actually happens is what actually happens is let's say I take a strong nucleophile. I take a strong nucleophile, and I in that nucleophile I put a base. I put a base. Base having a is having negative part, a negative OH part. So OH part basically is a basic part, and this basic part actually comes in, and that takes away the proton from the nucleophile, due to which the nucleophile, which was originally a weak nucleophile, became a strong nucleophile. Became a strong nucleophile, and that strong nucleophile then attacks over the carbonyl compound, due to which this reaction, this carboanion is formed, and that carboanion further takes the proton back in order to regenerate the catalyst. So this is the entire thing. Such that first step includes the formation of strong nucleophile, second step is formation of carbanion, third step is regeneration of catalyst. and then we have addition of hydrogen cyanide based on this mechanism. Whenever we are going to take sodium cyanide and HCl, then it's going to produce an acidic salt, an acidic salt which is known as hydrogen cyanide. What actually hydrogen cyanide does is, sorry, basically this is an acidic salt. This is um, no, this is not an acidic salt. This is a basic salt. This is a basic salt, right? This basic salt when reacts with HCl is going to produce hydrogen cyanide. What actually hydrogen cyanide does is, um, um, this hydrogen cyanide reacts with formaldehyde or any sort of carbon compound to form this thing: formaldehyde cyanohydrin, acetaldehyde cyanohydrin, and acetone cyanohydrin. Now let's just understand the mechanism, that how does it actually happen. So whenever we are going to take hydrogen cyanide, basically what actually happens is the hydrogen cyanide is ionized. Actually, hydrogen cyanide is not ionized. So we actually use a base which is having the cyanide ions. A base which is having the cyanide ions. So a base which is having the cyanide ions is used. This is a base which is having the cyanide ions that's released, that ionized to form the cyanide ions, and those cyanide ions attacked over the carbonyl compound, due to which it formed this carboanion. First step, which is the formation of carboanion, and in second stage what actually happened is the carboanion then took a proton from the hydrogen cyanide, due to which it became a cyanohydrin, alongside which the cyanide ion was regenerated. So this is the entire mechanism. Now what actually happened in this mechanism is, why do we do this reaction in these two steps? We can directly take cyanide ion from hydrogen cyanide, due to which we can actually get cyanohydrin. The reason behind it is that cyanohydrin cyanohydrin uh, present in the hydrogen cyanide cannot be ionized. Hydrogen cyanide cannot be easily ionized in aqueous solution, due to which we need to have a strong nucleophile attacking over the hydrogen cyanide in order to break its bond and form the cyanide ion, due to which we follow this entire mechanism. That first the cyanide ion from another base comes and attacks over the aldehyde and thus forms cyanohydrin, and then that cyanohydrin carboanion attacks over the hydrogen cyanide, due to which it forms cyanohydrin, and then the cyanide ion is regenerated. So this is the entire mechanism. And another important point is that this reaction takes place in an aqueous solution. In aqueous H2SO4. Why do we take an aqueous H2SO4? Even though we don't need an acid, there's a base catalyzed reaction. H2SO4 is not even being utilized as a base. So basically, why do we use first an aqueous solution? Because uh, in an aqueous solution we have got these things. In an aqueous solution we have got this, right? We have got the proton and we have got the hydroxyl ions. What actually happens is this proton comes, and what actually it does is it compels this bond to break. This compels this bond to break, as a result of which it forms the cyanide ions. It forms cyanide ions. And these cyanide ions, what actually these cyanide ions do is, these cyanide ions then go through this entire mechanism and produce cyanohydrin. So this is an important role of aqueous solution. And second thing is, why do we use H2SO4? What actually happens is the cyanohydrin needs to be treated with a dilute acid. It needs to be treated with a dilute acid in order to produce something I call as alpha hydroxy acids. What is this? Alpha hydroxy acid, basically it is any acid which is having the number of carbon atoms uh, one less than the parent compound. For example, the parent compound, sorry, one more than the parent compound. The For example, in this case, if you just see this, the parent compound is having three. Parent compound is acetaldehyde, which is having two carbon atom. But in the if you were to supposed to see in the alpha hydroxy acid, which is the lactic acid, hydroxypropanoic acid, that is having three carbon atoms. So in this type of reaction, for the synthesis of alpha hydroxy acid, this type of acid is known as alpha hydroxy acid, and for the synthesis of this type of acid, we use dilute sulfuric acid in it, aqueous sulfuric acid in it. Otherwise, instead of sulfuric acid, we can also use few more other things. Like if you're supposed to use, we can use let's say instead of sulfuric acid, I can use HCl, HNO3. So these are certain things which can be actually used. And then we have another reaction, which is the addition of sodium bisulfite. That's a reaction which can be done. It is primarily done to separate carbonyl compounds from non-carbonyl compounds. What actually happens is when formaldehyde reacts with sodium hydrogen sodium bisulfite, this compound, then it's going to produce this adduct. This is basically known as an adduct. And this bisulfite addition product, also known as bisulfite adduct, basically is precipitated in the form of a crystalline solid white crystalline solid. So whenever we are going to add an aldehyde or methyl ketone in sodium bisulfite, it's going to give us the white crystalline precipitates of bisulfite adduct, which that's the reason it is used as an it is used as an identification test for it is used for as an identification test for aldehydes and methyl ketones. And if you were to look into its general mechanism, the general mechanism is like this. So basically, if you just first understand that how we can obtain we can separate carbonyl compounds from non-carbonyl compounds, what we actually do is whenever we are going to have aldehyde or ketone in a solution, we put sodium bisulfite in it, due to which it forms bisulfite adduct. And that bisulfite adduct, because it is in solid form, it is easier to separate. We can physically separate that bisulfite adduct and then put it into a separate container and treat it with dilute mineral acid like HCl or H2SO4, and heat it up, due to which we will get the product back, which is acetaldehyde and water and sulfur dioxide. So in that way, we can easily separate carbonyl compounds from non-carbonyl compounds. Now let's look into the general mechanism of how does the mechanism works. So basically, when the sodium bisulfite separates into two major ions, number one is proton and second one is this ion. This ion is basically a strong nucleophile that attacks over the carbon, due to which it forms this carboanion, and that carboanion further accepts a proton, due to which it forms a bisulfite atom. Let's just move on to another reaction, which is a condensation reaction. A condensation is type of reaction in which there are two or more than two similar or dissimilar aldehydes or ketone combining with or without the elimination of water molecules, due to which there is a long chain of polymers formed, which is known as condensation reaction. A condensation reaction which happens in aldehydes and ketones is condensation or ketone condensation. Why do we call this aldol or ketone condensation? The reason behind it is that the product which is formed, it is having an aldehyde or ketone group plus an alcohol group, due to which we call that as the product as aldol, right? So let's just understand the mechanism first. Let's say if I take an aldehyde, I take ethanol, acetaldehyde, right? And I take hydroxide ion. Hydroxide ion is a strong nucleophile which is obtained from water. So basically what actually the hydroxide ion will do, it will take away the alpha hydrogen. Another important thing that I would like to share is that this mechanism can only happen if there is the presence of hydrogen on alpha carbon. We have studied previously in nomenclature that this is, let's say, a carboxyl group, or this is, let's say, CHO. Now whatever carbon is attached next adjacent to the functional group would be named as alpha carbon, and the next one would be called as beta, then gamma, then delta. In that way the entire sequence would be there. So if there is presence of hydrogen on alpha carbon, then condensation can happen. If the hydrogen on alpha carbon is not present, then condensation will not happen. For example, in trimethyl, let's say if I take trimethyl trimethyl acetaldehyde, I take trimethyl acetaldehyde, will I get, I take trimethyl acetaldehyde, so will I get, will I get a condensation product? I will not get an aldol. I will not get a condensation product because it is not having any alpha hydrogen. So this is a point to consider. So let's say if I take acetaldehyde, acetaldehyde reacts with hydroxide ion, due to which it takes the alpha hydrogen, due to which it forms water molecule and carbanion. The carbanion further reacts with another ethanol, due to which it produces an alkoxide ion. What actually the alkoxide ion does is, the alkoxide ion, oops, I guess that mechanism is not pasted over here in this slides. Anyways, I'm just verbally explaining it. So what actually happens is the alkoxide ion, yes, it is here. So what actually happens is the alkoxide ion, the alkoxide ion, this is the alkoxide ion, right? So what actually happens is this alkoxide ion is protonated, and because of the protonation happening, there's a regeneration of the catalyst, such that the proton which was already taken is given back to this alkoxide ion, due to which an aldol is formed, alongside which there is the formation of regeneration of the hydroxide ion. So this is the entire reaction, and these are some common products of aldol. For example, when ethanol and ethanol are combining, two same aldehydes are combining, it is going to produce butanol. When let's say a propanol to same two different aldehydes are combining, then it can also produce some product. By the way, the catalyst used over here, resistance and acid base catalyzed reaction, we can use dilute sodium hydroxide, we can use barium hydroxide, we can use any weak base as well. So this is the thing. Let's move on to the Cannizzaro reaction. Cannizzaro reaction is pretty simple. It is example of a disproportionate reaction. Again, for this reaction we need an alpha hydrogen. Alpha hydrogen is required. Alpha hydrogen is required. And an important thing is, it is a disproportionate reaction. What does this mean? Disproportionate reaction is type of reaction which is having the same compound is being oxidized as well as reduced in the same reaction, which is known as a disproportionate reaction. Let's see how it is done. For this we need a catalyst which is 50% concentrated aqueous sodium hydroxide or potassium hydroxide solution. And what actually happens is, let's say I take formaldehyde and I have used a 50% concentrated aqueous sodium hydroxide potassium hydroxide solution. I will actually get two things. Number one thing is an alcohol which is produced as a result of reduction, and I will get sodium salt of a carboxylic acid which is produced as a result of oxidation. So again, that's something pretty important. So mechanism is pretty simple. What actually happens is, first the strong nucleophile attack from the base attacks over the formaldehyde, due to which it forms an carbanion. That carbanion further reacts with another carbanion further reacts with another aldehyde molecule, other carbonyl molecule, due to which it forms two things. It forms two things. Number one thing which is formed is formic acid. Two things. Number one thing which is formed is carboxylic acid, and the other thing which is formed is alkoxide ion. What actually happens is, now the formic acid and alkoxide ion both react with each other, due to which due to which the hydrogen is taken away, and that forms a methanol, alongside which, sorry, not this hydrogen, but this hydrogen is taken away, and this hydrogen is taken away, due to which it forms a methanol, and then there is formation of a format ion. and that formaldehyde further reacts with sodium hydroxide, due to which further reacts with sodium hydroxide, due to which what it actually forms is what it actually forms is it forms the sodium salt of formic acid, and alongside that there's regeneration of the OH. This is the entire reaction. Let's say if I take benzaldehyde, it is going to be oxidized as well as reduced, oxidized into sodium benzoate and reduced into benzyl alcohol. This is an important thing. Now let's understand another important reaction that we have already done, known as haloform reaction. Haloform reaction is again, it's the basis of the iodoform test. Iodoform test, which we performed in the alcohols chapter. Iodoform test, it's simple. What we actually do is, let's say if I take an aldehyde, let's say we have understood that iodoform test is used to distinguish between methanol and ethanol. Things like ethanol, and methyl ketone give a positive test for iodoform test, right? There is, let's say, if I want to distinguish between methyl ketone and other ketone, if I want to distinguish between uh, methanol, sorry, if I want to distinguish between, oops, if I want to distinguish between ethanol and other aldehydes, then it is going to form, then it is going to give a positive test. So let's say if I take let's say if I take this ketone, this is a methyl ketone, right? I take methyl ketone and react it with halogen in the presence of sodium hydroxide solution. Then it's going to give me four things. Number one thing is haloform, which is the yellow precipitate of haloform, sodium carboxylate, and sodium halide, and the water is formed. Now, this haloform is the yellow precipitate, which basically indicates that there is presence of either an ethanol or a methyl ketone. Likewise, acetaldehyde can be, um, this is the entire same reaction that we did here. Acetone can be, found out in that way as well. And likewise, if we just talk about alcohols, then what type of alcohols can undergo iodoform test? Alcohols such as primary alcohols like ethanol can do the iodoform test. Secondary alcohol, which is having OH group on the second carbon, can do this test, but tertiary alcohol cannot do this test at all. No test possible. So this is an important thing. Now let's just move on to another important thing that I am going to put forward, which is the acid catalyzed reaction. Acid catalyzed reaction is the general mechanism of this. Basically, what an acid does, it increases the electrophilic characteristics of carbon, due to which the a weak nucleophile can easily attack on it. So what actually happens is, sorry for alright. So for the acid catalyzed reaction, we need a strong nucleophile, and for the base catalyzed reaction, we need a weak nucleophile. There's a correction which needs to be made. Alright. So what actually happens is the acid combines with the oxygen, due to which it forms this oxoniamine, and that oxoniamine further reacts with the strong nucleophile, due to which it forms this compound. So when we are going to perform, when we are going to react formaldehyde in the presence of H2SO4, polymerization of formaldehyde in the presence of H2SO4, we are going to form metaformaldehyde. When we are going to perform polymerization of acetaldehyde, then it's going to produce paraaldehyde. And these are important reactions. Let's just move on to another one. Reaction of ammonia derivatives. Whenever we are going to, let's say, an amine group attached to um, a particular group which is attached to amine group forms is an ammonia derivative. When that ammonia derivative reacts with aldehydes or ketones, it is going to produce at first an amino alcohol, which is an unstable thing that takes a water molecule away, due to which it produces a condensation product. This reaction can also be named as an addition elimination reaction. Addition elimination reaction. Why do we call it addition elimination reaction? Because it has addition procedure occurring alongside the elimination reaction occurring together, which we call it as an addition elimination reaction. And we can also call it as a condensation reaction because it's basically having condensation by the removal of water. So this is the reaction. Now let's just understand few important reactions of ammonia derivatives. For example, let's say if I'm having a amine group attached with an OH, then it is going to be named as hydroxylamine, and that hydroxylamine reacts with acid with aldehyde in order to produce oxime. So oxime group is like this. Oxime group is this. This is an oxime group. This is an oxime group, right? And then we have ethanol. Whenever we are going to react aldehyde with uh, phenylhydrazine. Phenylhydrazine is like this. This is what we call as a phenylhydrazine. That's phenylhydrazine when reacts with aldehyde is going to produce phenylhydrazone. Phenylhydrazone. This is a phenylhydrazone. This is phenylhydrazone. And then we have um, hydrazine. When hydrazine is going to react, it is going to produce hydrazone. And then when the 2,4-dinitrophenylhydrazine is going to react, it's going to produce 2,4-dinitrophenylhydrazine. It is going to produce 2,4-dinitrophenylhydrazone. So this is an important thing. Now this basically is used as an identification test. The test of 2,4-dinitrophenylhydrazine when it is reduced into 2,4-nitrophenylhydrazone, it forms a yellow or orange crystals which can be used for the identification of aldehydes or ketones. This is an important thing. What is the mechanism? Let's look at the mechanism as well. So mechanism is in such a manner that proton attacks on the carbon due to which it forms a carbocation. Carbocation attacks over the nitrogen of the ammonia derivative, uh, due to which it produces this amino alcohol. Amino alcohol releases a water molecule due to which it forms releases a proton due to which it forms this intermediate. That intermediate further loses one proton and H2O molecule. Within that intermediate, we add a proton to the OH group due to which it forms H2O, and then that H2O alongside the proton is removed out due to which we form this ammonia derivative. This is the mechanism. And now we have the addition of alcohols. Addition of alcohol is pretty simple. When we are going to react aldehydes with alcohols in the dry alcohol in the presence of dry HCl, it's going to produce diethoxyethane. Diethoxyethane, 1,1-diethoxyethane, which is known as an acetal. And when that can again be hydrolyzed in the presence of dilute acid or water to produce back the compound we already which was parent compound. And this test is not eligible for ketones. Ketones cannot do this test. Now let's just move on to another important part, which is the reduction reaction. Reduction reactions are very simple. We have two types of reduction: chemical reduction and catalytic reduction. If we talk about catalytic reduction, that is done in the presence of a very high temperature of something around 200 300 centigrade, and catalyst is palladium, platinum, or nickel, due to which we get alcohols. If it is formaldehyde, then we are going to get methyl alcohol. If it is acetaldehyde, then ethyl alcohol. If it is acetone, then we are going to get isopropyl alcohol. If we are going to get acetone, then it is isopropyl alcohol. And when we are going to react perform chemical reduction requires a strong oxidizing agent. If it is in the case of, let's say, if it is in the case of an aldehyde can even be, aldehyde and a ketone, both of them require a strong reducing agent, which is sodium boron hydride and aluminum sodium boron hydride and aluminum lithium hydride. Among both of them, lithium aluminum hydride is a stronger one. It is a stronger one. So this basically, uh, in the presence of lithium aluminum hydride or sodium boron hydride, we can actually get the alcohols, and alongside that, the mechanism is like this. We first, the hydride comes as a strong nucleophile and attacks over the carbon, due to which it forms a carboanion, and then the carboanion, basically we can also call this carboanion as alkoxide ion. Alkoxide ion takes a water molecule, due to which it forms an alcohol. Now we are not going to regenerate the protons. We are not going to regenerate the hydride ion which is already present, because it is a reduction reaction and an not a addition reaction. Here the hydride which is used is not used as a catalyst but as a reagent. So this is an important point to consider. So now let's just move on to oxidation reaction. Oxidation reaction is again pretty simple. We are going to take two conditions. Number one is the condition for aldehydes, and number two is the condition for ketones. If we talk about aldehydes, they can be oxidized by both mild oxidizing agent as well as strong oxidizing agent. For example, mild oxidizing agents like uh, chromic acid, Tollens reagent, valence solution, and Banach solutions can be easily helpful for aldehyde to oxidize them. Likewise, a strong oxidizing agent like potassium dichromate, potassium permanganate, um, pyridinium chlorochromate can be used in order to oxidize them. So acetaldehyde can be oxidized into acetic acid, uh, propionaldehyde can be oxidized into propanoic acid, and in that way these can be oxidized into their respective acids. Now ketone has a problem. Ketone has a big problem that it cannot have mild oxidizing agent which can oxidize it, such as Benedict solution, Fehling solution, Tollens solution give cannot oxidize ketone. So we cannot even perform the identification test for ketone with the help of Tollens reagent, Benedict solution, Fehling solution. For that, we need a strong oxidizing agent like pyridinium chlorochromate (PCC), potassium dichromate, or potassium permanganate. These are some important things required. Alright. So acetone is oxidized into acetic acid, and butanol in acetic acid as well. In two acetic acid molecules. There's an important point to consider over here. When we are going to have a symmetrical ketone, when I'm going to have a symmetrical ketone, then a symmetrical ketone is going to give me two products, a mixture of two ketones. But an asymmetrical ketone is going to give me only one type of ketone. Sorry, only one type of acid, one type of carboxylic acid. Symmetrical ketone is going to give me two types of acids. For example, in case of dimethyl ketone, we are having acetic acid and formic acid as a product. And another important thing to remember here is that another important thing that is important to understand is that symmetrical ketone, whenever you're going to have an unsymmetrical ketone, in an unsymmetrical ketone, the carbon atom is added, the the oxygen is added. By the way, the oxygen is only added to the oxygen is only added to the oxygen is only added to the carbon, to the hydrogen which is attached to carbon, due to which it forms an OH group, and that basically forms uh, is only added to the hydrogen which is attached to the carbonyl carbon, and rest of the chain remains intact, due to which this reaction is carried out in that way. And another important thing to be remembered is that oxygen is attached to only a particular carbon, or a particular hydrogen atom, due to which forms OH group, and thus a carboxyl group is formed ultimately. and that happens in case of unsymmetrical ketones. In unsymmetrical ketones, the oxygen is added. Unsymmetrical ketones, oxygen is added to the unsymmetrical ketones. The oxygen is added to the carbon which is having the least number of hydrogen atoms. This is an important point to consider. So this is all about it. Now there are certain tests for the identification purposes, whether the compound is aldehyde or ketone. Number one test is a DNPH test or dinitrofenyl hydrazine test, in which we get 2 for dinitrophenyl hydrazone, which is a yellow or orange colored crystal, which indicates that there is aldehyde or ketone. It is applicable for both aldehyde or ketone. Sodium bisulfite test, in which we get sodium bisulfite adduct, which is yellow precipitate, white crystalline precipitate actually, which is eligible for methyl ketone and aldehydes. Then we have tolerance reagent. Tolerance reagent basically is a freshly prepared reagent. This reagent cannot be kept for a long time, so we need to freshly prepare it. We take silver nitrate and we take ammonium hydroxide, and then which ultimately produces complex of silver ammonium complex. This silver bisulfite, this silver bis ammonium complex is then reacted with the aldehyde in order to, which basically produces silver mirror, which is produced on the inside of the tube. A silver mirror is produced on the inside of the tube, which basically uh, indicates that there is presence of an aldehyde, alongside which we have ammonium carboxylate, and then we have ammonia and water. So silver mirror is very important because it is used for the high quality manufacture of silver mirror, which is present on the mirrors, and the silver which is present on the mirrors. So this is the reaction. After that we have Phalanx solution. Phalanx solution is of two types. Phalanx solution A, which is having copper sulfate solution, aqueous copper sulfate solution, and phalanx solution B, which is having sodium hydroxide with sodium tartrate. Sodium hydroxide with sodium tartrate, right? So what we actually do is, when we're going to both solutions are blue. Both solutions when mixed together they are bluish in color. So phalanx solution A and B are mixed together, alongside which aldehyde is added into the phalanx solution, and they are heated up. And when they're heated up, the blue color of the phalanx solution is converted into brick red precipitate. Is converted into brick red because of the presence of the brick red precipitate of cuprous oxide. What actually happens is the copper, which is having its valency as +2, is changed into +1. It is actually reduced, due to which there is a brick red precipitate of cuprous oxide appearing in the solution. And alongside that, there is formation of sodium salt of carboxylic acid and water. So this is the entire reaction. Now Benedict solution is, again, it's the entire same thing. The only difference which comes in is, instead of tartaric acid we are going to use citric acid. Instead of tartaric we are going to use citric acid, and the sodium, so instead of, basically, this is the entire thing that is present in the Benedict solution. Instead of sodium tartrate we are going to use sodium citrate, and that citrate further reacts to form again the brick red precipitate and the sodium salt of carboxylic acid and H2O. This is the entire thing, same reaction. After that, we have sodium nitroprusside. Alright, so these three reactions, Benedict solution, Phalanx solution, and tolerance reagents, are not eligible, not applicable for ketones. Ketones do not give this test. Now, sodium nitroprusside is a test that ketones as well as this is a test which can only be given by ketone. Aldehydes cannot give this test. Aldehydes cannot give this test, and ketones can only give this test. What actually happens is, we take a ketone and we put drop wise sodium nitroprusside over the ketone, due to which it produces a wine red or orange red color, due to which it produces a wine red or orange red color of the solution. Let's now understand the uses of aldehydes and ketones. So, the first thing we need to understand is that the thing which we call as formaldehyde, thing which we call as formaldehyde is of particular commercial importance. I'm going to give the reason as well that why it is of particular commercial importance. First and foremost, formaldehyde is used for the synthesis of dyes. It is used for the synthesis of dyes like rosalin, uh, pararosalin, pararosaline can be made with the help of this. And alongside that, we can also make resins like urea formaldehyde, and plastics like bakelite can be formed with the help of this. And alongside that, it is used for making formalin, which I already told that is an important antiseptic, disinfectant, biological specimen preservant, and fungicide, pesticide. And then it is used for the synthesis, it is used for silver mirroring, silvering of mirror. And then we have formation of urotropin drugs. Urotropin drugs are urinary tract antiseptics, the urotropin drugs. Another important thing is that it is a carcinogen as well. It is a carcinogen. So this is a disbenefit of it as well. Alongside which, there is it can also form formaldehyde can also combine formaldehyde can also be combined with lactose to form what we call as formamint. Formamint, and that formamint is a throat lozenge. Throat lozenge. Throat lozenge. Right. And alongside that, it is also used for it is also used for the formation of anti-polio vaccine. Anti-polio vaccine. These are some important characteristics. Number two is acetaldehyde. Acetaldehyde. Acetaldehyde, basically, number one thing which you need to consider is that acetaldehyde. Number one thing which we need to consider is acetaldehyde can be used for making alcohols. It can be used for making carboxylic acids, for making esters, for making paraldehydes can be used for making vicinal acetate, can be used for making uh, anhydrides. So these can be made. It can also be used for silvering of mirror, silvering of mirror, and alongside that, it can also be used for making chloral hydrate. It can also be used for making chloral hydrate. What is a chloral hydrate? Chloral hydrate, and there's another compound which we call as ethanol trimer. Chloral hydrate and ethanol trimer, both of them are hypnotic drugs. They cause hypnosis, hypnotic drugs. Alongside which, they are also used for making tetramer, ethanol tetramer, and that ethanol tetramer is a slug poison. It's a very dangerous thing, so it's an important point. And alongside that, it is ethanol tetramer. And there's another important thing I would like to share, that it is used for the manufacture of antibiotics. And It is also used for making it is also used for making ammonia acetaldehyde, ammonia acetaldehyde, which is a rubber accelerator. Ammonia acetaldehyde. This ammonia acetaldehyde is a rubber accelerator, right? So an accelerator in the synthesis of rubber, accelerator in the synthesis of rubber. And another important thing is that acetaldehyde can be used for the formation of resins, resins of phenol. It can be used for the synthesis of resins of phenol, phenolic resins, and certain compounds. Resins of phenols in synthetic plastics. And synthetic plastics. So these are certain important things to consider. I hope you enjoyed the video. Hopefully, we'll meet again in another video.